if she will make half rotation, what is her speed? Her speed is equals to distance by time. So distance means 2 pi r. 2 pi r half rotation. So half means what? By 2 divided by t. So it will get pi r by t. Now, in this case, what is the velocity? What is the velocity in this case? That is what. So velocity, know that displacement, yes or no? So displacement by time. So now displacement means the Vardhini stopped at point B. So when she stopped at point B, this is the initial point and this is the final point. What do you mean by displacement, Danishkar? The shortest distance between, yes or no? So shortest distance between them. What is the shortest distance between them? This point, what we used to call? That is only we used to call as, so center point C. So this is what we used to call as diameter. So this is radius and this is radius. So that is what we can say. So by the time, what is the velocity? Velocity is equals to what? Diameter. So diameter divided by time. So because diameter is equals to what? Diameter is equals to displacement. Clear, everybody? That is what you have to remember. Okay. Now, my question is, as I told you, so before I taught you one point, can you read that point, anybody? After this example, I taught you one point. Can you read that point? Anybody? Please respond. The direction of acceleration is along the direction of change in velocity of the body. Is it yes? Is it the point I taught you? Yes or no? Now you tell me. So when the body is in circular motion, continuously velocity is changing. At every point, continuously velocity is changing. Is it true or not, everybody?
Yes, sir, true.
Now, what about the acceleration? If velocity is changing, is it acceleration also changing?
Yes, sir.
Yes? Yes, 100%. So when the body is in circular motion, at every point, velocity changes. If velocity changes, then who will change?
Acceleration.
Acceleration also will change. That is what I want to say. That is the meaning of that point. Have you noticed it, guys? The direction of acceleration is along the direction of change in velocity of the body. Do you understand it? So when the velocities keep on changes, then who will change?
The acceleration.
Acceleration also will change. That is what you have to remember. So this is all about it. What is acceleration? Then for our today's class, we'll study what is the units of acceleration. Then later next class, we'll study types of acceleration and all. Is it okay, Harish? Now, keep it in all of you. Units of acceleration. Units of acceleration. Again, we need 2 units. What is that units, guys?
CGA and SI.
SI unit. Understanding? That is what. So CGS and SI unit is enough. So now shall we start, everybody?
Yes, sir.
Yes. Now let me. If we'll take first, as we know, acceleration formula. What is the acceleration formula? Final velocity minus initial velocity divided by time. Okay. Now you tell me first of all, CGS unit. So CGS unit, what is the unit of velocity? CGS unit, check your notebooks and tell me. Last class I taught you. Velocity unit, CGS unit. CGS unit, velocity, guys, centimeter per second. Yes, please. Yes or no? Centimeter per second. Now time, what is the CGS unit of time? Second. Yes, everyone? Yeah. Now you substitute in the formula. So acceleration is equals to change in velocity. So units is remain same. So what is the units? Centimeter per second divided by time units is what? Second. Is it okay, guys? Is it okay, guys?
Yes, sir.
I can write this one. How I can write? Centimeter per second. Now mathematics, how it will be turns into, tell me. 1 by second. Reciprocal. Yes or no, Harish? Nothing is there means 1 will be there. Have you noticed it? I am assuming here nothing is there means 1 will be. That is what. I should not write that, but you all, I hope you all understand that. Yes or no? That is what. So you can do this one. What will come? Centimeter into 1 centimeter. Second into second, what, guys? Second square. Yes or no? So 2 into 2, 2 square. How will write? Same way. S into S, what we can write? Second into second. Second into second, what we can write? Second square. Okay. So how to read this one? Anybody can read? How to read this one? Centimeter per, understanding, second square. Okay. Second square. So centimeter per second square we used to call it as. So that is the CGS unit of acceleration. So this one you can write like this: centimeter second minus 2. Do you remember I taught you correct how to write this one? So 1 by x, you can write x power minus 1. 1 by x square, how I can write? X power minus 2. Now same way here, this one I can write 1 by s square. How I can write, guys? S power minus 2. Understand everybody?
Yes, sir.
Yes, that is what. So kindly write it. That is the CGS unit. What is the CGS unit of acceleration? Centimeter per second square. How to read that? Centimeter per second square. Or you can read centimeter second inverse. This one I can read. This one I can read as a centimeter per second square. Or I can read this one as a centimeter square inverse. Sorry, second square. Sorry, sorry. Centimeter second inverse. Centimeter what? Centimeter second inverse. Okay, that is what? Inverse square race. Centimeter second inverse square. Square, it is correct. Inverse. Inverse means minus. That is what? So centimeter second inverse square we used to call it as units of CGS unit of acceleration. So centimeter per second square. Any doubt, guys? How to read this one, Danishka? Centimeter per second square. That's all. Now, is it completed, guys? Everybody respond.
Yes, sir.
Yes, sir.
Now, as we know, next one, SI unit. SI unit is both units we must know. SI unit. So what is the SI unit of, again, velocity? Again, SI unit of velocity. You have to tell me. Meter per second. And time. What is the time? Time. Okay. Now you can take acceleration is equals to what will come units. You should tell me by this time. I should not say one only. I can. You have to remind himself. So meter per second by second, which is equals to meter per second into 1 by second, which is equals to meter per second square. No, or we can say meter second inverse. Understand? Inverse square. So this is what we can say. CGS unit of what is that? CGS unit of, sorry, SI unit of, SI unit of acceleration. Acceleration, that is what the unit. So please kindly write it. Clear?
Yes, sir.
Do it fast. Any doubt?
No, sir.
No, sir.
So now, so what is the 2 units of both of you? All of you tell me what a CGS unit of acceleration is. Centimeter
Per second square.
Next one. And
Meter.
SI unit is what?
Meter per second square.
Meter per second square.
That is what you have to remember. Now, as we know, what is the acceleration formula? Please respond. Acceleration is equals to what? Change in velocity means final velocity minus initial velocity divided by. Now you also tell me, as we told down, what we should say, Harish? Down what we have written? Tell me time or time taken for change in velocity.
Time taken for the change in velocity.
For change in velocity. Yes or no? Yes. So that is. So now, for example, see, now here is Danishkar is started. Now Danishkar starting time t is equals to 0. Now his velocity is something. Let me imagine 0 meter per second. Now this is initial velocity. Now final velocity he reached after 5 seconds. Means t is equals to 5 seconds. His velocity reached to 15 meter per second. His velocity reached to what? 15 meter per second. Now, what is this acceleration? Tell me anybody. Acceleration is equals to what? Final velocity means 15 minus initial velocity 0 divided by final time. Yes or no? T2, this is T1. So final time, D2 minus T1, final time minus initial time. So that what will come? 15 minus 0 divided by 5 minus 0, which is equals to 15 by 5. 5 ones are 5. How much? 5 threes are, which you can say 3 meter per second square. How much? What is the acceleration?
3 meter per second.
Second square. This is the acceleration of Danishka. Yes or no, guys? So that is what.
Yes,
So keep it in mind so that I can say acceleration formula: final time minus initial time. Is it yes or no? Final velocity minus initial velocity. Final time minus initial time. Is it yes or no? Please respond. So T2 means
sir.
final time, and T1 means I can say initial time. Any doubt? Anybody? So any interval it will come. Okay. Now keep it in mind. I will make you simplified formula. Change in velocity, final velocity minus initial velocity, we can represent with instantaneous velocity. How we can return? Check in your notebook and tell me. Instantaneous velocity. Change in velocity for a short period of time, we used to call it as instantaneous velocity. Yes or no? Yes,
sir.
please. So we written what? Delta V, something we written. Check it out. Delta V divided by delta T. Yes or no? That is what we can say. Change in velocity. Yes or no? So this is what we can say. So rate of change of velocity, we can represent with understanding delta V minus final velocity minus initial velocity, we can represent with the delta V, and final time minus initial time, we can represent with what, guys? Delta T. Do you understanding, everybody? Yes, please respond.
Yes,
So
sir.
that is what. See, velocity means we can say change in displacement divided by change in time. Yes or no, Harish? Check your notebook. Delta S divided by delta T. Have you remembered? Yes or no? This is change in velocity. Instantaneous velocity is equals to change in displacement divided by change in time period. Have you remembered, Harish, this formula? Everybody, this is the formula, instantaneous velocity.
Yes, sir.
This is what we have been studied. Yes or no? Now, same way, this delta S means what here? Anybody can tell me what do you mean by delta S? Delta S means what there? Change in displacement in small interval of time. Change in displacement
in small interval of time.
Yeah, given period of time. Have you drawn that graph also? Have you drawn that graph?
Yes,
Two graphs you have drawn. Now,
Yes,
here,
sir.
same way, change in velocity. For velocity, change in displacement. For acceleration, change in velocity divided by change in time taken. So that what is the formula will come, guys? Anybody? Simply want to write acceleration is equals to, how I can write? Acceleration A is equals to delta V divided by delta T. Is it yes or no? That's all. This is what we can say acceleration formula. So this is what you have to remember. So delta indicate what always? Change. Understanding? Delta indicate change in, that is delta symbol. This is called as delta. So delta V means change in velocity. Delta time means change in time period. That's all. So this is what we used to call as acceleration. So if you'll understand this, then next class we are going to study the types of acceleration. That is what the first type of acceleration called as uniform acceleration, and the next one will go for the directly types of another type of acceleration, non-uniform acceleration, uniform acceleration and non-uniform acceleration. And the same way, always is our speed is keep on increasing velocity. Suppose if you want to move, you will increase your velocity. If you want to come to rest, you will increase your velocity or decrease your velocity. Decrease or velocity. So that is also called as acceleration only. So change in speed, either increasing speed or decreasing speed, both are used to called as acceleration. But we have some other different name for decreasing velocity. That is all the things we'll discuss in the tomorrow's class. So with this I will stop. So thank you all of you. We'll meet in tomorrow's class. Thank you all of you. Everybody.
Thank you, sir.
Sure.